Uninspired, Bluebird has suffered a problem. His fleet boat has run out fuel in the middle of the high seas and must arrive at noon to find a treasure on the lost island. Its major storms are forecast after that time. They have found two ways to get and must choose which is the best option. The first one with current at room temperature and the other at one temperature. Also, fortunately for them, they've come across 2 gallons of different types of fuel. Now, we must help them to choose the best course and fuel to get to the treasure as quickly as they can and avoid storms.
Hi guys, I'm Fabiola Gutierrez.
And I am Maria Jose Peñarrieta, members of the AIChE Ecuador K-12 team.
We're here to guide you in experiment called racing boats.
With this, we will develop the theory of the surfactants and its applicability in an interesting case.
Go for it! The materials we need are 2 disposable plates, round tip scissors, ruler, 2 cotton swabs, towel or paper towel, 2 colors of liquid food coloring, toothpicks, rope, glass or plastic tray, tube tape, 2 glasses, liquid soap, and liquid detergent, measuring cup and tap water, 2 liters or 64 ounces, thermal protective gloves, a cooking pot, Scotch tape, 2 teaspoons a cooking stove. We will start by making a small fleet of boats to help Bluebird. To do this, we will consider the following procedure. Take a disposable plate and use half to draw one boat. To do this, you could use the ruler, taking approximately the measurements from the figure shown. Or you could print a template that we made to help you. Then, with the round tip scissors, proceed to cut the boat. Then use the other half to do the other boat. Take the second disposable plate to draw and cut the 2 missing boats, following the procedure of the previous step. Measure 1 liter or 32 ounces of water into a measuring cup. And put that amount in a cooking pot. To heat for 4 minutes. At medium temperature, not high, medium. Without forgetting to control the time with the current meter. The same amount of tap water is remeasured into the measuring cup, which we must pour into a tray to be used. Dry the edges of the tray with the towel in case they have water residues. Then take the rope and cut considering the length of the tray. a rope into the water but only superficially, that is, without completely submerging it. Then tape the ends of this to the respective ends of the tray.
Okay guys, in the next step we will pour about 2 teaspoons of liquid detergent and liquid soap in each glass. Let's not forget in which glass we put the liquid soap and in which glass we liquid detergent. Children, what do you think will be the fuel that will make the boats move faster? Liquid soap or liquid detergent? We will know that later. Now we must choose a coloring for the boat with liquid soap and another for the boat with liquid detergent. I will choose green for the boat with liquid soap and blue for the boat of liquid detergent. Then we will put a drop of coloring at the end of the balls. We will leave the balls in that position, making sure that the drop doesn't fall. We will take a swab for each ball and immerse it in the glass with liquid soap and in the glass with liquid detergent respectively. Well guys, the next 2 steps we will try to do it very quickly. If we have someone to help us, great. First, we take our balls very carefully and place them in the water, making sure that the drop of food coloring touches the water. Then we take the swabs at the same time, place them at the end of the opening of the balls, considering the color we have previously established for the liquid soap and liquid detergent.
Measure the trays left by the balls with a ruler. So for the detergent we have 20 centimeters approximately, and for the soap we have 15 centimeters approximately.
Hey guys, did you know why this happened? Let's go! To understand this, we have first to define the concept of surface tension. Surface tension is that force that holds the molecules on the surface of a liquid together, forming a layer. This characteristic of the surface allows a liquid to resist an external force. It can be easily observed when certain objects float on the surface of the water. For example, mosquitoes are capable of running on the surface of the water. Remember how you feel when you dive into a pool? It feels hard, right? This is due to surface tension. It acts like a skin over water or like a thin layer of plastic wrapped on water. In this experiment, that's the reason the ship doesn't sink. Now talk about surfactants like soap and liquid detergent. These are chemical substances that are located on the surface of a liquid or between 2 phases with the aim of changing the surface tension. What happens with cutting a stretched rubber band? The end where it is cut is pushed away by the tension in the rest of the rubber band. Similarly, detergent and soap lowers the surface tension of water into a degree that is like cutting the surface of the water. In the experiment, the rest of the water surface is moved away from the point where it is cut, and with it managed to move the boat by dragging. But why soap and detergent can break down or lower the surface tension? Well, this is because soap is a substance that loves the water but also loves fat, that allows water and fat to join simultaneously. Even though it is unlikely these two will unite and if they are alone, and without forgetting that there is a surface barrier or a skin of water. So surfactant is like that friend who is a peacemaker and has the ability to join 2 groups of people in fights, breaking the barrier of resentment, building bonds of friendship between the 3. To explain the difference between soap and detergent, first consider that using tap water is not the same that using rainwater or other types, because tap water has more quantity of substances like calcium, the one in milk. These kind of substances are called minerals and are generally found in the soil. Water that contains a great amount of minerals is called hard water. You may notice water hardness when your hands still feel slimy after washing with soap and water. Soap and detergent are surfactants, so why is they behavior differently? Detergent also has a water-loving and fat-loving side, but its water-loving side loves considerably more the water than the soaps. So when interacting with the minerals in the hard water, the water-loving side of soap is not good enough to keep acting by bonding to the water. Instead, detergent, apart from reacting less with minerals, even when it does, the water-loving side is strong enough to keep its function. So detergent has more effectiveness than soap. Continuing with examples, surfactant as a peacemaker, if soap is a surfactant, the strength of its relationship with one of the groups is not good enough in comparison with detergent as surfactant. Therefore, for breaking the barrier of resentment and constructing bonds of friendship with this group, or in the experiment breaking the surface tension and constructing bonds with hard water, detergent is more effective. Resuming, the water-loving side of surfactants is what makes the difference between the existing types like soap or detergent.
The first part of the experimentation is finished. Now, pour the water that was used for this first part. Using protective gloves, pour the water that was heated in one of the previous steps into the tube. So, what do you think will be the current that will make the boats arrive faster? The water current or the room temperature current?
Following the previous procedure, we will place a drop of the food coloring select for the boat with liquid soap, and we will do the same procedure with the food coloring select for the boat with liquid detergent. I will leave the boats in that position, ensuring that the drop doesn't fall from the boat. We will take a swab for each bottle and immerse it in one in glass with liquid soap and the other in the glass with liquid detergent. Now we will place our boats on the edge of the table so that the drop is off the table. Well, now we pull a toothpick in each boat. In the same way, we will try to do the two steps that come on very quickly. First, we will take our boats through the water, but taking from the toothpick, without forgetting to use the protective gloves, taking care that the drop of food coloring touches the water. Remember, that is warm water, so toothpick or gloves are important as a precaution. Then we take the swabs and at the same time we place the swabs at one end of the opening of the boats, considering the color that we have previously established for the liquid soap and liquid detergent. With a ruler, we will measure the color laid by the two boats. For the liquid soap, 19 centimeters. For the liquid detergent,
21 centimeters.
So, in which environment was the speed of boats favored? At room temperature or at warm temperature?
Let's talk about the effect of temperature in surface tension. As temperature increases, the surface tension decreases. This is because the temperature gives energy to the water, so within the water movement begins to cure, and that decreases the strength of the bonds that keeps the water together, facilitating the water surfactants of breaking surface tension. Imagine you are all seated in the classroom, but the alarm that indicates dismissal time sounds, so you prefer to run out of the classroom instead of remain sitting with your friends because your pets and family are waiting for you at home. In this case, the alarm acts as a temperature giving them pause.